Welcome to the deep dive. We're plunging into a topic that's really fundamental. It's all about bridging the secure world of blockchain with the messy real world you and I live in.
Yeah, it's a fascinating space.
Think about that core paradox, right?
Hmm.
Blockchains are these incredibly secure, reliable systems, almost like a superpowered computer,
Mm-hmm.
but they're isolated, completely cut off, like that computer having no internet connection at all,
Mm.
blind to everything outside their own network.
And that isolation, that deterministic nature, that's their strength in many ways. But yeah, it's also a massive limitation. How does a smart contract, say, trigger a payout when your flight gets delayed if it can't know the flight was delayed?
Exactly. Or how does a DeFi protocol figure out the constantly changing price of Ethereum or Bitcoin?
It can't, not on its own. Without some kind of connection, smart contracts are just stuck. They can only play with the data that's already inside the chain.
And that's where blockchain oracles come in. They're the essential service, the critical bridge, really, the middleware that connects this secure digital island to that huge dynamic ocean of real-world data.
Right. And for this deep dive, we've gathered quite a bit of material, some articles explaining the basics, others really digging into the significant security challenges, which are key,
Yeah, those are important.
and also insights into how the tech is evolving, especially this move towards decentralized networks. We even have some, community chatter on where things might be heading.
So our mission today is to walk you, the listener, through this really critical piece of infrastructure. We want to pull out the most important bits, what oracles actually are, why they're so indispensable, how they, pull off this
All
connection.
mechanics of it.
Exactly, the mechanics, plus the big challenges they face, and that's a major part of the story and how the latest solutions are trying to tackle those problems. The aim is for you to get those aha moments, to grasp what's really important, and pretty quickly.
Sounds good.
Okay, so let's unpack that core idea first, the bridge between worlds. At its heart, what is a blockchain oracle? Can we define it simply?
Yeah, I think so. At its simplest, it's basically a third-party service.
Mhm.
Its whole job is to grab information from the outside world, off-chain sources, and securely feed it into smart contracts on the blockchain.
So it kind of translates the real world for the contract.
Exactly. It encapsulates all that real-world complexity.
And the why is key here, isn't it?
Yeah.
Smart contracts, by design, are isolated.
Yeah.
They're deterministic. They don't have a built-in web browser or an API hookup to the internet or anything like that.
Precisely. That's fundamental. Without oracles, a smart contract is just stuck processing what's already on its own chain. Very limited view.
Right.
Oracles are what let them, break out of that box. They allow contracts to react to real-world stuff. Price feeds, sports scores, weather reports, data from web APIs, IoT sensors, even data from other blockchains. They unlock so much potential.
There was a simple example in the sources, the gold price bet. That really makes it clear.
Mm.
So say you and I make a bet on the price of gold using a smart contract. We lock our crypto in. But when it's time to settle up, how does that contract know the actual current real-world price of gold?
It just can't know on its own. It's impossible from within the chain. That smart contract absolutely needs an oracle to act as that bridge.
Okay.
The oracle goes out, reliably fetches the accurate gold price, probably from multiple sources off-chain, and then delivers it onto the blockchain so the contract can see it and use it to settle our bet fairly.
Okay, so they're the necessary bridge.
Yeah.
Makes sense. But how do they actually do that? What are the mechanics? How does that data get from, say, a weather website onto the blockchain?
Right. Well, first, it's important to understand what oracles aren't. They aren't the weather website itself or the stock exchange or whatever the original data source is.
Okay, not the source.
No, they're the mechanism, maybe a network, that talks to those sources, verifies the data that's crucial, and then transmits it securely.
Gotcha. So they're the layer between the real-world data and the smart contract. The sources laid out a kind of general workflow, didn't they? It starts with a request.
Usually, yeah.
Actually-
A user, or often the smart contract itself, sends out a data request when it hits a point where it needs external information to continue its logic.
And that request is specific, like, I need the temperature in London.
Exactly. It specifies what data is needed, maybe preferred sources, maybe even how to combine answers if there are multiple sources. This request goes to an on-chain part, like an oracle contract.
Okay, an on-chain contract manages things.
Right. It manages the process and sort of translates the request for the outside world. This oracle contract then typically creates a log event. Think of it like raising a flag signaling, hey, Data needed over here.
And who sees that flag?
The off-chain Oracle nodes. These are computers running Oracle software, constantly listening for those specific events on the blockchain. One of these nodes picks up the task. Now it steps off the blockchain and into the regular internet world. It makes the actual API calls standard web requests like HTTP, GET to fetch the data from the weather website or financial data provider or whatever was requested.
So the node does the actual fetching.
Right. And once it gets the data, the off-chain node might do some work on it. Maybe check it, combine it with data from other sources if the request specified that, and importantly, reformat it into a clean, simple format the blockchain can easily understand.
Because blockchains like things simple.
Very much so. Then finally, that processed, ready-to-go piece of data is sent back on-chain. It's submitted in a transaction to that original Oracle contract.
And the smart contract can then read it from the Oracle contract.
Precisely. And the really neat part, as mentioned in the sources, is that all the complicated stuff, calling APIs, maybe complex calculations, dealing with different data formats, happens off-chain.
Where it's cheaper and faster.
Exactly. You're not constrained by blockchain things like gas fees or block confirmation times for all that external interaction.
Okay, concept clear, mechanics make sense. So what's the bigger picture? What's the real impact? How do oracles fundamentally change what blockchains and smart contracts can actually achieve?
Oh, the impact is huge. I mean, first and foremost, they provide that vital access to external data and APIs. Suddenly, smart contracts can talk to web services, IoT devices, traditional financial systems, pretty much anything outside the chain.
Which opens up so many possibilities.
Totally. It's essential for building useful, dynamic applications in areas like DeFi, obviously, but also supply chain, insurance, gaming, you name it.
Right. And it improves the smart contracts themselves too, doesn't it? Makes them smarter.
In a way, yes. By giving them access to real-world conditions, they can make genuinely informed decisions. They can automate processes that depend on external events or data points. They become truly reactive to the world, not just processing internal chain state.
That makes sense.
There's also a scalability angle, interestingly. By pushing complex computations or data fetching tasks off-chain to the Oracle network, it takes load off the main blockchain.
Oh, right. So the main chain can focus on just processing transactions.
Exactly. It helps keep the main chain more efficient. And while we absolutely need to talk about the security challenges later,
Definitely.
a well-designed Oracle system also aims to enhance security and reliability for the data itself. They use things like cryptographic proofs, data aggregation, reputation systems to try and ensure the data they deliver is accurate and hasn't been messed with.
Okay, so they try to be part of the solution too.
And finally, they're key for interoperability. Bridging blockchains to traditional systems like banking or even helping different blockchains share data. Oracles often play that intermediary role.
Let's make this concrete. Where are we seeing oracles being used right now? What are some killer apps that just couldn't exist without them?
Well, decentralized finance, DeFi, is definitely the biggest user today. It's almost entirely reliant on oracles because DeFi protocols need constant, reliable, real-time financial data. Think prices of crypto assets, exchange rates between currencies, maybe interest rates, trading volumes. All that stuff changes constantly.
Right, for lending, trading.
Exactly. For lending protocols to manage collateral, for decentralized exchanges to offer fair prices, for derivatives platforms, they all need accurate price feeds. Projects like Chainlink, Band Protocol, UMA Oracle, they're major players providing this data.
A lending protocol absolutely needs to know the price of collateral. Otherwise, how does it know when to liquidate?
Precisely. It can't operate in the dark. Another huge area is getting real-world event outcomes onto the chain.
Like what?
Think about insurance. A smart contract for crop insurance could automatically pay out if an oracle confirms that rainfall in a specific area was below a certain level based on verified weather data.
Okay, that's cool.
Or betting markets settling based on the final score of a sports game confirmed by an oracle. Disaster relief funds being released based on reports from verified sources. Our sources mention Pith Network and Witnit in this kind of space.
Verifiable randomness is another interesting one you mentioned. Why is that hard on a blockchain?
Because blockchains are deterministic. Everything that happens is predictable based on the inputs. That's good for security, but terrible if you need genuine unpredictability, like for a lottery or drawing winners in a game fairly.
Ah, so you can't just ask the blockchain for a random number.
Not a truly random, unbiasable one. So oracles provide this service. They generate randomness off-chain using cryptography, prove it was generated fairly, and then deliver that verifiable random number to the smart contract. API 3, QRNG, and Chainlink VRF were cited examples.
Makes sense. Supply chain too.
Yep. Tracking goods using data from GPS sensors, RFID tags, temperature monitors, verifying authenticity using external databases. Oracles feed that data into supply chain smart contracts to trigger actions like confirming delivery or releasing payment.
And automating the contracts themselves. How does that work?
Sometimes a smart contract needs a certain function to be called regularly, maybe for maintenance, or only when a specific condition is met off-chain. Doing this reliably and in a decentralized way is tricky.
So you need something to poke the contract.
Kind of, yeah. Services like Chainlink's Keeper Network use decentralized Oracle nodes to monitor conditions and automatically trigger those contract functions when needed. It's like decentralized automation for smart contracts.
Okay, so lots of uses. But you mentioned oracles aren't all the same. The sources broke them down into different types, right? What are the main categories we should know about?
Yeah, there are a few ways to slice it. Probably the most critical distinction is based on how they're managed, their trust model.
Okay.
You have centralized oracles. These are controlled by a single entity, often relying on just one data source. And the sources were pretty clear this is a big red flag.
Because it's a single point of failure.
Exactly. One point of failure, one point of control, one point of potential manipulation. It kind of undermines the whole point of using a decentralized blockchain.
Right. So what's the alternative?
Decentralized oracles, usually called decentralized oracle networks or DONs, these are the direction the space is moving. They use a network of multiple independent nodes.
Spreading the trust.
Precisely. And they often pull data from multiple sources too, then aggregate it. This massively reduces those single points of failure and control.
Okay, centralized versus decentralized is key. What other ways can we categorize them?
We can look at the direction of data flow. You have inbound oracles. These are the most common bringing data into the blockchain. Things like prices, weather data, sports scores.
Data coming in.
Right. And then outbound oracles, which send information from the blockchain out to the real world, like telling a traditional payment system to send money or instructing a smart lock to open based on an on-chain event.
Interesting. Inbound and outbound. What about the source of the data?
Yeah, you can distinguish based on that, too. Hardware oracles get data from physical things, sensors, barcode scanners, IoT devices. They're translating physical events into digital data for the chain.
Like a temperature sensor for that insurance contract.
Exactly. And then software oracles, which are probably more common right now, they pull data from online sources, web APIs, websites, databases. Think financial data, flight statuses, that sort of thing.
Okay. Hardware, software. Any others worth mentioning?
The sources briefly mentioned a few others. Human oracles, where actual people verify information, often using cryptographic signatures to prove their identity. Computation oracles perform complex calculations off-chain that would just be too expensive or slow to do directly on the blockchain.
All right, this brings us to the elephant in the room, the big challenge you mentioned, the oracle problem. Introducing this external data seems to bring back the very trust issues blockchains were designed to solve. What exactly is this problem?
That's the core tension, exactly.
Exactly.
Blockchains are built to be these trustless, decentralized environments where you don't need to rely on any single intermediary, right? But to do anything useful involving the real world, they have to rely on an oracle to feed them that external data. The oracle problem is this fundamental challenge. How do you ensure that this bridge, this oracle feeding data in, is actually trustworthy and reliable? How do you prevent it from becoming the weak link that compromises the whole system?
And the sources pointed to two main trust issues, did they? Data accuracy and oracle reliability.
Yep. First, is the data itself correct? Has it been tampered with? Is it actually accurate? Second, will the oracle service itself stay online? Will it function correctly? Can it be hacked or shut down?
And the risk, especially with those centralized oracles we talked about, is huge. They become this single point of failure.
Totally. It's the Achilles heel. A compromised or faulty centralized oracle can completely undermine the security and decentralization benefits you thought you were getting from the smart contract.
They could be manipulated. They could just go offline. The operator could even feed bad data intentionally.
All of the above. There's a quote in one source that really hit home. Your smart contract is only as strong as its weakest link, and any breach in the oracle can have serious negative consequences. It really is this critical bottleneck of trust.
So what are the specific risks people worry about? And crucially, how are solutions evolving to deal with them? The sources detailed a few key ones.
Yeah, they did. Risk number one is just using low-quality data inputs. Getting data from, say, a free, unreliable API versus a professional paid data feed. Garbage in, garbage out.
Makes sense. So the fix.
Use premium data providers with strong reputations and service-level agreements. And the Oracle mechanism needs to be able to handle secure API keys or credentials so the nodes can access these better sources.
Okay, what's next?
Risk two, relying on a single data source. Even if it's a good source, it's still just one source. It could have temporary glitches. It could be manipulated. Think about flash loan attacks targeting a specific exchange's price feed.
Oh, right. Or it might not reflect the true market price if volume shifts elsewhere.
Exactly. So the solution here is data redundancy and aggregation. Don't trust just one source. Get data from multiple independent, high-quality sources. Aggregate those data points, maybe using a volume-weighted average price calculated across many exchanges. And, importantly, have mechanisms to identify and discard outliers that look suspicious.
Okay, multiple sources, aggregate, filter outliers. Good. Third risk.
Relying on a single Oracle node to fetch and deliver the data. Even if it's accessing multiple data sources, if only one computer, one node, is responsible for bringing that data on-chain.
That node is still a single point of failure. It could go down, it could be hacked, its operator could be bribed.
Precisely. Centralization risk, again, just at the node level, the solution. Decentralized Oracle networks, DIANs. Use many independent Oracle nodes run by different people or organizations. Aggregate their responses.
So you're decentralizing the data delivery as well as the sourcing.
Exactly. You're not trusting one node operator. You're trusting the consensus or the aggregate result from a whole network of them.
Okay, that makes sense. Risk number 4.
The quality of those node operators themselves. Running a secure, reliable, high-uptime Oracle node isn't trivial. It needs technical expertise, good infrastructure, constant monitoring, serious DevOps. If nodes are run by amateurs...
The whole network's reliability suffers.
Right. So the solution is for Oracle networks to attract and incentivize professional, experienced node operators. Teams with a proven track record of running secure infrastructure. It needs to be treated as a professional operation.
And the last one mentioned was about transparency.
Yeah, opaque Oracle mechanisms. If you don't know how an Oracle system works internally, what sources it uses, how nodes merge consensus, what its performance history looks like, how secure its software is, you're basically accepting unknown risks.
Flying blind.
Pretty much. So the solution is to prioritize transparent, open-source Oracle solutions. Systems where you can see the code, monitor performance in real time, and verify data integrity, perhaps through things like cryptographically signed data submissions on-chain that create an immutable audit trail.
Okay, so it sounds like the clear evolutionary path, the main answer to this whole Oracle problem, is these decentralized Oracle networks, the DAWNs. Is that fair to say? They're the way forward.
Yeah, I think that's absolutely fair. DAWNs are really the primary way the industry is tackling those fundamental trust and security issues. By distributing trust across multiple nodes and data sources, they aim to eliminate those dangerous single points of failure.
And how exactly do they distribute that trust? What's the mechanism?
Well, the core idea is having numerous independent nodes all perform the same task, like fetching a specific price. They each get their answer, and then they need to agree on the correct answer before anything gets submitted back to the blockchain.
So they talk to each other off-chain.
Often, yes, or they submit their individual findings on-chain to an aggregation contract. There are different models, but the key is some form of consensus or aggregation mechanism. This collective validation filters out incorrect or malicious data from a single rogue node or source. You'd need to compromise a significant number of independent nodes to manipulate the final result.
Right. So the advantages are pretty clear then. Better security, more trust.
Definitely. Enhanced security and trust because no single party is in control. Improved data accuracy because you're averaging or finding consensus among multiple inputs. Filtering noise.
More resistant to manipulation.
Much more resistant, yes. And better reliability, too. If one node goes offline, the network keeps functioning because the others are still there. It's distributed infrastructure.
Makes sense. But are they perfect? The sources mentioned challenges still remain.
Oh, for sure. It's an evolving field. Challenges include things like designing the best consensus mechanisms, ensuring the economic incentives truly keep node operators honest and reliable long-term, preventing collusion between nodes. There's still ongoing research and development. But DAWNs are a massive improvement over centralized oracles.
Now, when we talk about DAWNs, one name just kept popping up again and again in our sources, Chainlink.
Yeah, you can't really talk about oracles without talking about Chainlink. It's definitely highlighted as, probably the most widely adopted and prominent decentralized Oracle network out there right now.
And that community discussion piece we looked at really drove that home. Some people were saying it's practically becoming synonymous with oracles, almost like the Ethereum of oracles, given how foundational it seems to be for so many projects.
It certainly has significant market share and mind share. The sources touched on their vision, particularly Chainlink 2.0, which focuses on expanding what Dawns can do. Things like enabling more complex hybrid smart contracts.
Hybrid, meaning part on-chain, part off-chain.
Exactly. Seamlessly blending secure on-chain logic with powerful, scalable, and confidential off-chain computation and data provided by the Dawn. They're also focused on scaling these services, enhancing privacy and confidentiality for data, and really leaning into crypto-economic security.
Which means,
Basically using the network's native token, LINK in their case, for staking and penalties to financially incentivize nodes to provide accurate data and punish them if they don't, making honesty the most profitable strategy.
got it. And that Swift collaboration mentioned, that sounds like a big deal for bridging traditional finance.
Yeah, that's a major example of using oracles, specifically Chainlink in this case, to connect existing financial infrastructure like the Swift messaging network with various blockchain platforms, a real-world bridge.
But Chainlink isn't the only player, right? The sources mentioned others.
Whoa, absolutely not. It's important to know it's a diverse ecosystem. Sources mention Band Protocol, UMA, Pith Network, Witnit, API3, QRNG, or AI, DIA, Switchboard. Quite a few others are active in the space, often focusing on different niches or design trade-offs.
Like that comparison between Chainlink and Band Protocol.
Right. The source suggested, broadly, that Chainlink often prioritizes very high reliability and accuracy, maybe using more nodes and more complex aggregation, while Band Protocol might emphasize speed and cost efficiency, potentially with a leaner network structure. Different applications might value those trade-offs differently.
Okay, let's bring this all back home. For you, the listener, trying to get smart about this space, why is understanding oracles so fundamental? Why should you care?
Because honestly, they're kind of the hidden engine behind almost every blockchain application that interacts with the real world. If you're using a DeFi platform, playing a blockchain game with randomness, looking at supply chain tracking on-chain, or using parametric insurance, chances are there's an oracle working behind the scenes.
They're ubiquitous if the app touches reality.
Pretty much. These applications simply cannot function without that external data feed. So if you're evaluating a decentralized application or trying to understand how it works, you need to realize you're implicitly relying on its oracle system.
And knowing about the oracle problem, those risks we discussed, data manipulation, downtime, centralization.
Exactly. Understanding those risks and knowing how solutions like Dawn's try to mitigate them is absolutely crucial for assessing the real trustworthiness and security of any dApp that depends on outside information. You have to look beyond just the smart contract code itself to this critical data layer.
So wrapping up this deep dive then,
Yeah.
the core takeaway. Oracles are, well, indispensable. They're the literal bridge, the absolutely vital connection between isolated blockchains and the dynamic outside world. They're what unlock the potential for smart contracts to actually interact with reality.
Yeah, that's the gist of it. And making sure these Oracle solutions are secure, accurate, and trustworthy isn't just some minor technical detail. It's fundamental for the continued growth, adoption, and overall success of the entire blockchain ecosystem. It's the infrastructure layer that really determines if smart contracts can live up to their promise.
Okay, so here's a final thought to leave you with, something to chew on. If smart contracts are pitched as these unstoppable, autonomous, self-executing agreements, and their execution, their triggering, critically hinges on the information fed to them by an oracle, does the trust you ultimately place in that unstoppable contract really just boil down to how much you trust its oracle? Is the oracle the real linchpin of trust?